Today's lesson is both solving quadratic equations by inspection, meaning figuring out what's your best method, and also factoring when your leading coefficient, your A, is not equal to 1. So your warm-up right now is on page 5. You have 4 problems, and to help you, I've put the flow chart necessary or helpful to any factoring method in the middle. And from, I believe it's Ms. Strauss's lesson, that was the video you were supposed to watch before this one, I've also put the instructions step by step of how to factor when your leading coefficient A is not 1. Step 1 is to solve the quadratic for 0, meaning all of the terms on one side of the equal sign. Label your trinomial in, it's in standard form. So you're going to label your coefficients A, B, and C, because that'll be important for your factoring. You're going to create your T-chart, where you're going to take the A coefficient and the C coefficient, multiply them, and then see if those same factors that multiply to your number A times C add to your coefficient in the middle B. And then you're going to either split the middle and group using GCF so that you can get your 2 binomials multiplied, or if you are using the box method, you can also organize your factors that way. Either method, you're going to have to regroup all of the answers to your multiplication and division to get your 2 binomials. Please hit pause here so that you can work on this warm-up. For number 1, when I look at this quadratic, I can see it's 2x squared minus 18. If I go through the steps of the flow chart, I can see that there are 2 terms, and you can factor this by greatest common factor. 2 goes into both 2x squared and negative 18. So I divide both factors by 2, or both terms by 2. Remember, when you do each division, 2x squared divided by 2 and negative 18 divided by 2, you put what's the answer to the division in your parentheses and what you're dividing by on the outside. That is so important. So this is your first step in factoring. Now, when I look at x squared minus 9, I can see that there is a difference of perfect squares, meaning I can further factor x squared minus 9 into x plus 3, x minus 3, and again, don't forget to put the 2 on the outside. For number 2, this is a trinomial, meaning it has 3 terms, but this one also has a greatest common factor of 3. So I'm just going to move this out of the way, and I'm going to erase this. Hopefully I haven't erased the answer. Good, I did not. So if you look, your first step is to divide each term by 3. So you're factoring 3 out of 3x squared and out of negative 6x and out of negative 24. That 3 goes on the outside, and the answer to each of your division problems is left in parentheses. Now I have a trinomial that can be solved by splitting the middle. What 2 numbers multiply to negative 8, and those same numbers have to add to negative 2? Well, those numbers are 2 and 4, and if your term in the middle is negative, that means the larger number out of the factors of -8, that larger number is the one that needs to be negative. Again, the 3 is in front of your parentheses, and your factors are x minus 4, x plus 2. That's number 2 fully factored. For number 3, looks like I covered things up a little weird, but let me start moving some of these boxes out of the way. Here's your equation, 2x squared plus 3x plus 1. This cannot be factored by split the middle because of the 2 in front of x squared. It cannot be factored by GCF. So we are going to use the method in the previous video, factoring when a is not equal to 1. To start these problems, we are labeling our coefficients a, b, and c. And we are coming up with a times c. So our a coefficient is 2. Our c coefficient is 1. When I multiply them, I get positive 2. Any numbers that multiply to positive 2, those same numbers must add to positive 3. Well, luckily, the only numbers that really multiply to 2 are 2 and 1. And since everything's positive, I don't really have to worry about the different signs. From here, I can go 2 different paths. I can do grouping, where basically I have split the middle. I have changed 3x into 2x and 1x. That came from these two factors here. You can see my parentheses around the first 2 terms and the second 2 terms. And now in this method where a doesn't equal 1, our a is 2, you have to do a greatest common factor out of each set of parentheses. So out of 2x squared plus 2x, the greatest common factor is 2x. Out of the terms of 1x plus 1, the greatest common factor is 1. So from that step, we go here. And now I can see in common x plus 1, x plus 1. Since both sets of groupings has x plus 1 in common, this is the part in the instructions where we said to regroup. So by regroup, we are taking 2x and x plus 1, and we are combining them together to be one of our factors. So our 2x squared plus 3x plus 1, one of the binomial factors is 2x plus 1. The other factor is the factor they have in common, x plus 1, only written one time. If instead you choose to use the box method, you are going to use your split the middle. So you are going to use this term and this term in your 4 boxes. Notice that you can find them here and here. And in the first box is always the first term in your original trinomial, and the last box is the last term. Now you're doing greatest common factors between rows and columns. What is the greatest common factor that comes out of 2x squared and 2x? That is 2x. What is the greatest common factor that comes out of 1x and 1? That's 1. So one of my terms in my factoring is 2x plus 1. I'm just going to go along the sides outside of the 4 boxes. Now, to figure out what is the other factor on top, I'm just basically doing the division of what's outside the box. So 2x squared divided by 2x leaves 1x left over. 2x divided by itself is 1. And then I am confirming that my answers are correct by doing x times 1 is 1x, and 1 times 1 is 1. So I have confirmed that x plus 1 is one binomial factor, 2x plus 1 is the other binomial factor. And then rather than explain the last one, I'm just going to reveal everything, starting with our T-chart, where I do A times C. 3 times -10 is -30. The term in the middle is -1. That's our B. The two numbers that multiply to -30 are -6 and 5. Here is the factoring, doing it by grouping and GCF, and then regrouping based on what I factored out of each term, in this case 3x and 5. Or here is my box method. It'd be a good idea to pause the video at this time if you need to go over what these methods were for how we did this. Now do page 2. You're going to practice on 4, 7, and 8, which we left undone from Thursday. And these are A not equal to 1 factoring by either box or by our A times C, and then those same factors add to B. So again, pause your video, and I will reveal the answers and how to do them. The answer to number 4 is x plus 4, 3x minus 5, and I will show that method in a minute. 7 is 4x minus 1, x plus 8. And the answer to 8 is 3x plus 2, 5x minus 1. And here is the work for each of these problems. Again, pause the video at any time to copy down the methodology for each method. So for number 4, you can see all the factors written that multiply to -60. -60 came from multiplying A times C. The one that works is -5 and 12. -5 times 12 is -60. -5 plus 12 is the term in the middle, 7. This method was only done by box method. First term in the original problem goes here. Last term in the original problem goes here. Use your -5 and 12 to fill in the last boxes. Do not forget the x's. And now you're going to greatest common factor out of each row and column. 3x squared, 12x, 3x comes out. -5x, -20, 5 comes out. And then you're going to do the same thing on your rows. And then you're going to regroup. Here is one factor. Here is the other factor. Number 7. This, actually it's number 7 and number 8. You can see that both methods were shown here, both split the middle and regrouping, as you can see here. Split the middle, greatest common factor, regroup. And number 8, by box. The first term and last term multiply to -30, those leading and last coefficients. The numbers that multiply to -30 and those same numbers add to, let me see up here again, add to -2, is that right? I'm sorry, so I didn't get the middle term. So 10 plus -3 is +7. 10x plus -3x is +7x. Using your box method, you come up with 5x minus 1 and 3x plus 2 as shown below. Okay, so today's homework, you will have practice in doing this kind of factoring. Make sure you're able to do factoring trinomials when A is not 1. And if you want to learn how to do guess and check or practice that, you can come to extra help, and I'll help you do that outside of class. If you have homework questions. We'll go over those on Monday. That's from Thursday's homework. Today's lesson is on page 6, continued. We're going to start with some vocabulary. The vocabulary is zero product property, which you learned in Algebra 1. That property says if I have a product is two numbers or factors multiplied. If the answer to that multiplication is 0, then at least one of those numbers or factors has to be 0. So if I want to explain what that means in symbols or in algebra, as we've learned, when we say symbolically, we mean algebraically. For any numbers or factors that are A and B, and if I multiply them, that's your product, and the answer is 0, that tells me either A has to be 0 or B has to be 0 in order for the answer to be 0. And in our factoring, we learn that this is the standard form of a quadratic equation, and the A, B, and C are our coefficients for each of the terms. Today, using that vocabulary and what we've learned previously about quadratics, we're going to look at 1 through 4, and we're going to determine what factoring method is most efficient to factor the given quadratic, and then we're going to solve the factored quadratic problem. So I'm looking at number 1. It's x squared minus 64. You might recognize that from Thursday's lesson as being a difference of perfect squares. In a difference of perfect squares, I'm able to take a square root of x squared, a square root of 64, and if there is a negative term between the x squared and the 64, that tells me the factoring of the difference of perfect squares is first to take the square root of x squared to get x. So I have x and x indicated here. The square root of 64 is 8, indicated here and here. And then the negative between x squared and 64 says one term is positive and one term is separated by, one factor is separated by negative and one is separated by positive. Now, for these kind of problems, we go back to what our vocabulary said. Zero product property says I must have the quadratic in either standard form or in factored form set equal to 0 so that I can set each factor equal to 0 and solve for x. So x minus 8 equal to 0. So one of my answers for x is going to be x equals 8. X plus 8 equals 0 means my other answer is going to be x equals negative 8. So since it's a quadratic, two solutions. The solutions are 8 and negative 8. For number 2, I have a quadratic, and in my quadratic, there is no coefficient I see in front of x squared. If there's no coefficient in front of x squared, that coefficient is 1. So this is a split the middle problem where a equals 1. So I want two numbers that multiply to negative 20. Those same numbers have to add to negative 1. So those numbers are going to be 5 and 4. And it's 5 that's going to be negative because it's negative in the middle of my quadratic. Remember, to solve, you must always have both the standard form and the factored form equal to 0. Then the zero product property says take each factor and set it equal to 0 and solve for the x. So my two solutions for number 2, x equals 5 and x equals negative 4. Since it's x to the second power is the highest degree, there are 2 solutions for every one of these problems. Number 3 is our old buddy, a not equal to 1. So your factoring method for this is either going to have to be box or our T-chart with our grouping and our greatest common factor. A not equal to 1 means that the leading coefficient is some number other than 1. I cannot just split the middle. I must do A times C and see if the numbers that multiply to that number add to the number in the middle. So one of the things going on with number 3 that's different than the other problems is that I have the negative 12 on the other side of the equal sign. You cannot solve unless your quadratic is set equal to 0. So my first step is going to be adding 12 to both sides. Notice I'm not even labeling A, B, and C until I get 12 on the same side as 2x squared minus 11x. Now I'm ready to label my coefficients A, B, and C. Time to make our T-chart where we do A times C and B. So 2 times 12 is 24. 2 factors that multiply to make 24 are 8 and 3. And since it's negative in the middle, both my 8 and my 3 must both be negative so that they add to negative 11. From here, you're going to do it one of 2 ways. You're going to now use negative 8 and negative 3 to split the middle. Oh, look, I've already made a mistake. Look. These all have to be equal to 0. That's what the zero product property says. Since I rearranged it in this step, every step until I get x equals 0, every step along the way must be equal to 0. So I'm going to use my grouping of 2x squared minus 8x to factor out 2x squared. I'm going to use negative 3x plus 12 to factor out negative 3. And now I'm going to regroup, which says take your 2x and your negative 3 to make one factor, and then only write x minus 4 one time. 2 factors, 2x minus 3 equal to 0. So this is going to be a fractional answer, 3 over 2. And then our second factor, x minus 4 equal to 0. Add 4 to both sides, x equals 4. Those are my solutions to number 3. And if you wanted to do it by box method, here we go. After you use your T-chart to find negative 8 and negative 3, negative 8x goes in these 2 diagonal boxes. And remember, you're going to factor columns and rows. Last method is I have a term on one side of the equal sign and a term on the other side of the equal sign for number 4. Remember, my equation must be equal to 0. If my equation must be equal to 0, I'm going to start by subtracting 5x from both sides. That's going to leave a binomial. With a binomial that cannot be factored by difference of perfect squares, the only method you can do if it's factorable is greatest common factor. So after I have subtracted 5x from both sides, oops, that's supposed to have a little x there. I have x squared minus 5x equals 0. Remember, perfect squares say I can take a square root of x squared. Well, that works. That's x times x. But now in order to do difference of squares, I must have to take a perfect square root of 5x. Well, I can't take a perfect square root of 5x. So now I'm looking for a greatest common factor. The greatest common factor of x squared and negative 5x is x. So I've divided both of those terms by x. Don't forget, the x that is factored out must go outside the parentheses. The answer to each of the divisions goes inside the parentheses. And of course, in order to solve, my equation must be equal to 0. Set each factor equal to 0, x equals 0, so yay, nothing else to do for x equals 0. That's already solved fully. X minus 5, you're going to add 5 to both sides, and you're going to get x equals 5. Today's homework over the weekend is page 334 through 45, every kind of factoring that's possible, and I believe there's going to be a little bit of solving as well. Please give it the old college try. Have a great weekend, and I will see you on Monday.